Let's look at this question here. We are required to draw the graph, determine the equation when we are done, and also to shift the graph horizontally, and also to check as to what are the values of p, wherein we will have exactly one root. So don't worry, we'll get down to that quickly. So now I need us to check certain things. On a cubic function, when you derive a cubic function, the cubic function will give you certain elements or attributes. So now, this is what we do. Firstly, let's bring in the Cartesian plane before we talk about this problem. This is our Cartesian plane. We are going to utilize this particular Cartesian plane to solve the problem that we are having. Even though my Cartesian plane is not that straight, we'll try to use it. Okay, now this is the x-axis. Let's label this one the y-axis. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now, what we want to do now is to draw this particular graph, right? So we check the properties that we are given. They are saying f at -2. It means that, let's say this is -1, this is -2, -3, and -4. 1, 2, 3, then 4. 1, 2, 3, 4. 1, 2, 3, 4. So now, to draw this graph, they are saying f at -2. Remember, we are dealing with a cubic function. They are saying f at -2 equal to f at 1 equal to 0. So it means that at this point here, we are having a factor at -2. We are also having a factor at x equal to 1. So these are factors. It means the value of y at this particular point is 0. So they go on further to say that f at -1, somewhere here along this line, we are having another point. We don't know what this point is called. F at -1, it's 4. So they go on further to say that f at 0, which is the y-intercept. This one is automatic, it's the y-intercept. They are saying it's 2. They go on further to say, from the information that we are having here, remember, the minute you say f prime at x, the minute you derivate, you equate it to 0, you are getting a quadratic function. You are getting a quadratic function. So if you are to derivate, if you derivate, you'll get values of x. You'll get x values. You take those x values, you substitute them inside the original. You substitute inside the original cubic function, then you get y coordinates of the turning point. You get y coordinates of the turning point. So now, these x values that you are obtaining are the x-intercepts, of a quadratic function, So now, this is what we are going to do. This is what we are actually going to do. You will say, okay, this f prime at 1, remember, if we are having our function like this is the cubic function. Somewhere here, we will have the x-intercept for quadratic function. Along this point here, we'll have the x-intercept of the quadratic function. So our graph will be like this. This is f prime. This one is f. So now in this case, we are told that f prime at 1, it's equal to 0. F prime at 1 is equal to 0. So that is the x-intercept of, that is the x-intercept of a quadratic function. So that being of the quadratic function, it means that that is the x-coordinate of the turning point. So we are having x coordinate of the turning point in 2 points. We are having one at -1, but they said to us that -1 goes with 4. They also said that f prime at 1 is 0. And they also said f prime, I mean f at 1 is 0. So what we simply do, it means that at this point here, we are having 2 x-intercepts here. We are having 2 x-intercepts. So we are going to join these points like this. We merely join the points. So joining the points, we'll join them like this. You'll just have to pardon me. I mean, draw it according to scale. Yes, this is the turning point. Then from the turning point, we go to the y-intercept. Then this is the turning point and the x-intercept. So this is the graph of f. The reason why I've drawn it like this is because of this property here. I'll explain it to you quickly. So now, on our graph, if we are having a cubic function that is decreasing, or that has got a value of a less than 0, the quadratic function will also be less than 0, and it will be like this. So if we are having a cubic function that has got the value of a greater than 0, this is the cubic function greater than 0, it will start off like this. Also, its derivative will be like this. We'll have something of this nature. So now I need you to check the shape that I am having here. Need you to check this shape that I am having here. So now you look at this thing like this. They are saying, let's say they are saying f prime at x. Remember, when you derivate, let's call this one 1, this one -1, then let's call this one -1, let's call this one 1. So when you derivate a cubic function, you get a quadratic function, right? So now we check f at x less than 0. For what values of x is this thing below the x-axis? It's when x is less than, it's when x is less than -1 or x greater than 1. Secondly, for this one, if we are looking at that particular condition, it's when x is between -1 and +1. It's when we are saying the graph must be below the x-axis. I hope you understand. So now, what that basically means, the shape of a quadratic function is dictated by the shape of a cubic function. If the value of a on a cubic is negative, also on a quadratic function will be a negative. I hope you understand. So hence I've written it like this. So now let's go on to the second question. The second question says, determine the equation of f in the form y equal to. So now if you check, to determine the equation of a cubic function is of this form: y equal to ax cubed plus bx squared plus cx plus d. But if you check this one that we are having here, it's given to us in terms of points. It's given to us in terms of points. So what you simply do, you quickly check, okay, we are having a turning point. It's given to us in this form, y equal to a into x minus a all squared multiplied by x minus b. So now this one is because the x-intercept has a turning point on it. So you'll say y equal to, you substitute the x-intercept, and of which it's also a turning point, we'll have x minus, we substitute this point here, this one, which will be x minus 1, you square it multiplied by x plus 2, because we'll have x minus minus 2. So from this, you are going to simplify quickly, but you start off by substituting. What we substitute? You substitute a point that you can see, which is the y-intercept, or you can just substitute a point. So let's just take 2 and 0. Let's substitute 0 and 2. We'll have 2 equal to a into 0 minus 1 squared multiplied by 0 plus 2. Then 2 equal to a into 1, negative 1 squared multiplied by 2, wherein we'll end up with 2 equal to 2a. Then we divide both sides with 2. We remain with a equal to 1. So the value of a is 1. It's positive 1. Look at the shape and look at the value of a. They go hand in hand, or hand in glove. So now the second thing that we need is to expand that which we are having here, so that at the end of the day we can identify the value of a, the value of b, and the value of c, and the value of d. So we quickly go on to say y equal to, you can even call this one equation number 2 if you feel like it. It means that this one will be equation number 1. So you go on to say 1 into x minus 1 all squared multiplied by x plus 2. You get to expand this. You will have y equal to, open bracket, this will be x squared minus, plus x minus 2 multiplied by x plus 2. Quickly you try to simplify this thing, it will simplify to x cubed minus 3x plus 2. So this is the equation in the form y equal to, this is the equation. So now the question is saying to us, this is what we are dealing with. They are saying you must shift the graph horizontally. Ne? You must shift the graph horizontally. You don't even have to calculate anything. They are simply saying to you, shift this graph that you are having here. You have to shift the graph that we are having here. We merely shift it like this. They are saying the graph of g is equal to f at x minus 3. So you have to shift this graph and you write down those x-intercepts. So we are shifting this graph to the right. So we'll say from x equal to -1, when we shift 3 units, you'll have -1 plus 3. You will get those coordinate. We will get that coordinate, or that x value. You are also going to shift. You are also going to shift this point here that we are having here, which is, sorry, I meant to say you are shifting this one here, the x values, and also this one. You are moving from -2, you add this value, you will say negative of 2 plus 3, which gives us a 1. Then we are also dealing with this one. You are having 1 plus 3, which will end up giving us a 4. So you are just shifting the graph horizontal. If we had this one as plus, we'll be shifting our graph to the left. So the coordinates now will be the coordinates that we will remain with. The coordinates that will remain with now. Remember what I said? We are shifting the graph looking at the x-intercepts. We are shifting this part here, and we are also shifting this part. So the new graph now, we are going to have our coordinates like this. We'll have 1 and 0. These are the x-intercept. We'll also have 4 and 0. So this thing will shift to this part here. We'll have something like this here, and we'll also have something on this particular point. So now the question is saying to us, determine the values of P for which, remember here we are dealing with the vertical shifting of the graph. We are dealing with the vertical shifting of the graph. So we check the turning points, the y coordinate of the turning point. Remember here we had -1 and 4. Then here we had 1 and 0. So we want to check wherein we will have one value or exactly one root. So you are going to draw a line to check what should be the value of P that we can subtract with. Remember, this thing will be placed in a standard form. So what we need is something of this nature. It can be like this, or it can be like this. Meaning I'll have to extend this graph of ours. So if we are to extend the graph will be like this, right? So we want to have one root, exactly one root. So it means that the graph must be cut at one place. The graph must cut the x-axis at one place. So what value or values of P should we subtract with? Remember, this thing at the end of the day, it must be like this. It must be x squared minus 3x plus 2 minus P. So what should be this value of P that we get to subtract with so that this graph is cut at one place? It's more like we're dealing with the vertical shifting of the graph. So what we simply do so that at the end of the day we have one value of x here. You will do it like this. You will check, okay, if a value of P that I get to subtract with, it's more than 4, meaning that I will have 4 minus 5 maybe. It will end up giving me negative value of the turning point. It will give me a negative value of the turning point. So my graph will be something like this. The graph will end up being something of this nature, right? So do you see that the value of x now is 1? The root is only 1. Do you see? So if I get to subtract with a value that is greater than 4, which can be 5, I will have one root here. I'll have one root. So hence I'm saying it's either P is greater than 4, the value of P should be greater than 4, or let's check another turning point. We are having this one as a 0 here. So if we subtract with a value that is more than 0, let's say we subtract this thing with 2. We subtract with a 2 here. If we bring in a 2, what happens to the graph? What happens to the graph if we happen to subtract with a 2 here? this graph will shift down here. It will shift down here, and then the minute it shifts, we'll have two values of x here. If you check, we'll have two values of x. Do you see? If we subtract with a value that is more than 0, so this thing will be below the x-axis. So at the end of the day, we should subtract with a value that is less than, so that at the end of the day, your graph is only cut at one place. So those values will just be like this, will just be p is greater than 4, so that this graph is cut at one place, or p is less than 0. Hence, I've drawn these lines for you, this line here and also this line, so that this graph of ours is cut at one place only. I hope you understand.